While any law of physics that's broken is no longer a law of physics, that's pure logic. That's because physics is the description of the universe. But something has broken our laws of physics, and that is black holes. But still those laws remain part of physics. Isn't that weird? It is. After all, we're talking about black holes, regions we haven't seen yet. So it's definitely going to be weird. But the question is, what happens inside a black hole that breaks our physics? You're watching Into the Unknown, and in today's video, I'll be taking you to a black hole and explain what happens inside it, which break our laws of physics. But before we continue, take a moment to subscribe to Into the Unknown and click the bell icon. In 1783, an English philosopher, John Michell, got an idea that laid the foundations of one of the most enigmatic and mysterious celestial bodies. Building upon Newton's theory, which suggested that light is made up of small particles, John Michell realized that if these particles would emerge from the surface of the star, the gravitational pull of the star would reduce their speed just like how projectiles behave when fired upward from Earth. Michell further suggested that by measuring the reduction in the speed of light from a star, it would be possible to calculate the star's mass. Moving on, Michell knew that for any projectile to escape a star's gravitational pull, it must move faster than a certain speed, which is the escape velocity. A star's escape velocity varies with its size and mass. He further thought, what if there are stars with such strong gravitational pull that their escape velocity exceeds the speed of light? He realized that light from such stars would not be able to escape them, and instead fall back to their surfaces. This made him suggest that such celestial bodies would be invisible in the universe as no light would emerge from them. This was the first time an idea pointing to a black hole was conceived. However, since the idea was too ahead of its time, it garnered little attention. Furthermore, knowing the approximate speed of light at the time, John Michell conducted calculations through which he was able to conclude that for any star to have its escape velocity exceed that of the speed of light, it must be 500 times larger than our Sun. Fast forward, and Albert Einstein revealed to the world a brilliant theory of relativity. According to Einstein's theory of relativity, gravity could affect light by bending it. However, it could not change its speed. And that's because Einstein's theory of relativity stated that gravity was not a force, as it was believed to be earlier, but instead, gravity is the effect observed when massive celestial bodies warp the fabric of spacetime around them, and the curvature causes objects to fall towards them. This way, when light passes through a gravitational field, it is bent due to the curvature, but since gravity is not a force, the speed of light remains constant. So, this proved that Michell was wrong about measuring the mass of stars by measuring the change in the speed of light, but he surely was correct in pointing to celestial bodies which would trap light due to their immense mass. After releasing his theory in 1915, Einstein predicted that celestial bodies which are so massive that their gravity allows nothing to escape exist. And this was confirmed by Karl Schwarzschild, who used Einstein's equations to mathematically prove the existence of such celestial bodies, which we call black holes today. According to the theory and equations, it was suggested that when stars, much more massive than our Sun, collapse towards the end of their lives, their cores become so dense that they bend the fabric of spacetime to a point that the curvature creates such a strong gravitational pull that nothing, not even light, can escape it. This created excitement around the world. However, detecting such celestial bodies was a challenge. After this theoretical existence of what were not called black holes at the time was confirmed, decades passed, and then in 1964, astronomers detected a celestial source of X-rays through one of their sounding rockets. Further research and studies were conducted, and in 1971, astronomers concluded that the X-rays were being emitted by a bright blue star, which was orbiting a dark object. They said that the X-rays were being emitted because the dark object was stripping away material from the bright blue star and eating it, and this confirmed the existence of the first black hole. This dark object was given the name Cygnus X1, which is located in the constellation Cygnus. Prior to this, the term black holes did exist, but the terms which were used were dark stars or collapsed stars. However, John Archibald Wheeler, an American physicist in 1967, During one of his lectures at the NASA Goddard Institute of Space Studies, used the term black hole, following which the term was further popularized. Over time, many more black holes have been discovered, and there are three main categories of black holes. Stellar mass black holes are the ones which are formed when stars roughly 5 to 10 times the mass of our Sun collapse. Intermediate black holes are the ones which are formed when stars 100 to 100,000 times the mass of our Sun collapse. And then there are supermassive black holes, which are located at the centers of galaxies. Supermassive black holes have about millions to billions of times the mass of our Sun, and so far are the biggest of black holes. While we do understand how normal black holes form, we don't know how supermassive black holes form at the center of galaxies. Now, you might be wondering, if black holes are black and do not emit light, how do even astronomers locate them? But before we continue, take a moment to subscribe to Into the Unknown and click the bell icon. Once black holes form, they can grow more massive by consuming mass. The event horizon is a point close to a black hole, where the gravitational pull is so strong that nothing, not even light, can escape it. Anything that crosses into the event horizon cannot escape. However, the radius of the event horizon is normally less. There are celestial bodies which orbit black holes but don't fall into it. However, under the influence of strong gravity around a black hole, matter can accrete around it and undergo the process of accretion, during which the matter that is spiraling inward compresses and heats up immensely. These high temperatures cause the matter to emit X-rays and gamma rays. However, during the process of accretion, another interesting phenomenon takes place. There are magnetic fields in the accretion disk which are amplified when during the accretion process they are twisted and compressed. These powerful magnetic fields near the black hole launch the matter as powerful jets perpendicular to the accretion disk. These jets are so powerful and energetic that they travel near the speed of light. When astronomers are searching for black holes, they search for strong X-rays that are emitted by the matter in the accretion disk, or they can also locate black holes by detecting strong radio emissions, which are emitted by the powerful jets of matter being ejected from the black hole. Additionally, astronomers may also use other methods, such as studying the orbital motions of stars orbiting black holes. So, they look for stars orbiting and behaving strangely around empty space. However, there are many other ways astronomers hunt black holes, such as gravitational waves and microlensing. Now that you know how the existence of black holes was suggested, how do they form, what are they, and how do astronomers locate them, you might be wondering, how do they break or violate our laws of physics? So let's go back to 1974, when an English physicist, Stephen Hawking, presented his theory, which related to black holes. The quantum field theory explained that particles and antiparticles are constantly made and destroyed in space. However, Hawking proposed that near the event horizon, things become different. He explained, using his theory, that near the event horizon, one particle from the particle-antiparticle pair would fall into the black hole, while the other would be radiated away. The particle that would be radiated away carries energy, and this radiation was given the name Hawking radiation, a thermal radiation that carries no information. He further explained that the release of Hawking radiation from black holes would cause the mass and energy of the black hole to be decreased, and will eventually evaporate, and this process is known as Hawking evaporation. However, this radiation has not yet been observed directly, as Hawking radiation is believed to be very low energy and faint. When this theory was presented, it contradicted and potentially violated our laws of physics, and hence gave birth to a paradox. According to Stephen Hawking's theory, black holes emitted Hawking radiation which is thermal, which means it does not carry information. No matter if a star, a book, a planet, or whatever falls into a black hole, the emitted radiation is the same and carries no information about what was eaten by the black hole. This implies that black holes somehow destroy the information that goes into it, while on the other hand, it is a law of physics that information cannot be destroyed. This contradiction has no explanation yet as to why. If information cannot be destroyed, do black holes appear to be destroying information? This created a thought in the world of astronomy that our laws of physics break down at the event horizon, and what happens inside a black hole is unlike anything our physics can predict. This paradox and a major contradiction may only be resolved if we know what exactly happens to matter once it transcends the event horizon and goes inside a black hole. However, since no light can escape it, astronomers have never been able to see inside a black hole. And what further complicates stuff is that the radiation emitted by the black holes has no information of the inside. But astronomers have gone above and beyond to predict and suggest theories that explain what may happen inside a black hole. But before we continue, take a moment to subscribe to Into the Unknown and click the bell icon. One theory suggests the existence of a point inside a black hole called a singularity, a point of infinite density and gravity, a point where time and space break down, where our physics just cannot explain what may happen or is happening. There have been attempts to replace the concept of singularity with other concepts, such as the existence of Planck stars, where Planck-scale physics would be at play. Quantum gravity's influence would be significant, and quantum structures may exist with a totally different kind of a space-time. Another theory known as the firewall hypothesis suggests that there is a highly energetic and intense region around the event horizon, which burns any information that enters it. This theory also aims to resolve the information paradox by proposing that information is not lost or destroyed, but rather burned by the firewall. Another theory suggests that black holes contain wormholes, which are celestial structures that connect different regions of space-time and function as shortcuts in space. So, there is a speculation that black holes may transport us to a totally new location in space. Another very weird idea is that our universe is itself inside a black hole, and that black holes may contain new universes. But this would complicate things to a whole new level. Just imagine, if we, a universe, is inside a black hole, then there are other black holes inside this universe which is inside the first black hole. And then there are more universes inside the black holes in our universe, and hence other universes inside the black holes which are in the universes inside the black holes in our universe. This can just keep on going like the Pascal's triangle, right? With no explanation as to where to start and end. Within this theory, there can be another paradox. Did it all start with a black hole or a universe? Similar to whether the egg came first or the chicken. Confusing, right? However, mathematical calculations suggest that this is highly unlikely the case. But one thing is for sure, black holes are highly mysterious and complex celestial bodies which science has not fully explained yet. And the major factor behind this lack of explanation is that they are black. We just cannot see them. So therefore, it will take time for science to advance to a point where technology is capable enough of seeing inside black holes emerge, so that we can fully unravel these enigmatic celestial wonders. If you enjoyed this video, give it a thumbs up. Share your thoughts or questions in the comment section below. Don't forget to subscribe to Into the Unknown for more amazing content, and ring the bell icon to stay tuned.